Okay, so I thought it would be a good idea for me to go through some of these homework questions since I'm not really there, just to make sure that you guys are on the right track for this week. So it says a farmer wants to enclose a rectangular area using his barn as one side. So here's the barn. We're not going to put a fence right against the barn and fencing for the other three sides. So that means that when I'm going to be doing that, I'm going to be using fencing for here, nice little rectangular pen. And what happens is that this length right here, which I'm going to call y, and this length right here are possibly different. So he has 1,000 meters entirely to make this length, and this length. That's our given information, which means that's the information that you have a number that's associated with. So 2y's plus an x has to add up to 1,000 meters. That's like your given information. It's sometimes called a constraint. When we're doing these questions, it's really important that you figure out what you're trying to find the ultimate sort of equation for. And the ultimate equation here is for area. And if we're looking for the area of this thing, the area of that shape right there, it is x times y. So now the deal is that you have to link these two equations. You have to find an equation for area in terms of just x or just y. So what we want to do is we want to make sure that we solve this equation in red for the easiest variable, and I think it's probably easiest to solve for x here. So I'm going to go 1,000 minus 2y, and wherever I see an x, I'm going to plug it into that equation, just like we did when we did like a substitution type thing. So now I have area is equal to x, which is 1,000 minus 2y times y. And you always want to expand that equation. So you're going to get 1,000y minus 2y squared. And don't forget about proper order. So we're going to get negative 2y squared plus 1,000y. And this skill about trying to take the information and then put it in terms of one variable is going to be really, really important for this week of classes. Okay, so this farmer also wants to create a garden plot as shown in the diagram below left. Well, I unfortunately don't have the diagram below left. So I'm going to make it up. So let's say I have something that looks like this. Okay, so this may not be the question because I don't actually have the diagram with me for some reason. I don't know why. But let's just say it says something that looks like this. My whole idea of this question is that we're dealing with area, and area is length times width. So it's this length along here, which I'm going to call x, and this length along here, which is I'm going to call y. My given information is that with 1,200 meters of fencing, I've got, for x's, I've got 1, 2, 3, 4, 5 of them in this particular one. And for y's, I've got 1, 2, 3, 4 lengths that are the length of y. And together, those things are going to make 1,200 meters of fencing. So that's my given information. I personally don't know which one would be easier to solve for. I'm going to solve for y then. So 4y is equal to 1,200 minus 5x. I'm going to go up here for room. I'm going to divide by 4. So 1,200 divided by 4 is 300, and 5 divided by 4 I'm just going to leave as 5 over 4x. And I know that the equation that I'm trying to figure out for is the area. So area again is x times y. So I'm going to take this y value that we have here and I'm going to plug it in where I see y, and I'm going to get area is equal to x times 300 minus 5 over 4x. We're going to expand it, and we're going to get 300x minus 5 over 4x squared. And I'm just going to write a for area, proper order, negative 5 over 4x squared plus 300x. Okay, and that's that one. Getting the equation ready to do the next step. And the next step is our next class. Okay, a window has a rectangular base. I know what this one looks like. A rectangular base and an arched top. This is actually called a Norman window if you ever go into construction or design or anything like that. So this is called a Norman window. And there's a semicircle on top. So there's the center of my semicircle. And the perimeter of the window is to be 10 feet. Find an equation for the area of the window. So here's the thing. Now you've got two pieces. You've got a semicircle up here, and you've got the rectangle at the bottom. So what I did was I started with the semicircle, and here's my let statements. I let that be the radius, which means that this width of my rectangle is 2 times the radius because it goes straight across for this one. I let this guy be the height of the rectangle. You can use whatever variables you really want to. But the reason why I used radius is because it would really help with the circle situation, okay? So now it says the perimeter of the window. The perimeter of the window is this part, which is half of the circumference. Circumference, remember, was 2 pi r, so 1/2 of it, just pi r. Okay, so that's going to be that part right there, pi r. And then the rest of it, of the perimeter, is these things here. So here's what I've got for perimeter. The perimeter is 2r, which is the bottom, plus 2 h's, which are the two sides, plus pi r, which is the blue part on the top. And that perimeter was the given information. That's the 10 feet that we're dealing with. So there's one equation that I've got. It says now find an equation for the area of the window. The area of the window is going to be 1/2 pi r squared, so 1/2 of a circle at the top, plus base times height. Now when you take a look at trying to figure this thing out in terms of one variable only, let's try to figure out the easiest thing for us to do. So area is 1/2 pi r squared plus 2rh. In this equation right here, to me, it seems it would be much easier if I could just sub in something for h, because I'd only have to sub it in one time. If you're going to sub something in for r, you'd have to sub it in here as well as here, and that seems like too much work. So what I'm going to do is I'm going to take my perimeter equation, and I'm going to isolate h. So I've got 2r plus 2h plus pi r is equal to 10. So 2h, I'm going to leave that on one side, is going to be 10 minus 2r minus pi r. And I'm going to divide everything by 2 to make sure that I've got this kind of idea. My h value is 5 minus r minus, if you want to put 1/2 pi, oh, you can do that, or you can just put pi over 2r. And what I'm going to do is I'm going to take that h value and I'm going to plug it into there. That should give me my equation for the area. Area is going to be 1/2 pi r squared plus 2r times 5 minus r minus pi over 2r. Remember, always expand. It'll make your life a little bit easier. So I'm going to distribute, and I'm going to get 10r minus 2r squared minus pi r squared. The only thing that you might see, like in the homework or answers or something like that, is that I collected my like terms, and my like terms are 1/2 of a pi r squared minus 1 full pi r squared. So what I really get for this one is 10r minus 2r squared plus, nope, sorry, my mistake, minus 1/2 pi r squared. Now, it's not pretty. Nobody ever said that these were going to be pretty, but what you're trying to do is you're trying to practice your translation skills. And we're moving into these number questions. And the number questions are really important because a lot of people have trouble with the number questions when they put their let statements and stuff together, and you don't really have to, when you just think about it. Here's my let statements. Let the numbers be x and y, so that I know that they're not a and b or whatever it is that you might want to use, okay? So x and y. And then this is the given information. So that's the first thing we're going to translate, is that given information. And you have to follow BEDMAS. It says 3 less than, twice another number. BEDMAS means that you do your division multiplication before your addition subtraction. So you pick one of the numbers, okay? One number can be either x or y. It makes absolutely no difference. So I'm going to start off with y. Is in math right there translates to equals. And now we use BEDMAS for this little part right here. I do my multiplication first, so twice another number, twice the other number. And then 3 less than that means that I'm going to subtract 3 from it. Keeping that in mind that you're following the BEDMAS, this is always our sort of given information statement. It's like that perimeter that we did in the last question. Now it says find an equation for the product of two numbers. Product means that you are multiplying the two numbers that you're dealing with. So the x and the y, the product is x times y. Now you know what y is. You can plug it back in. You're going to get x times 2x minus 3. And so your product equation is 2x squared minus 3x. Now the next one says the sum of the squares. A square of something means it's the number squared. So the sum means plus. The two numbers are x and y, so the square of both of those numbers, and we're adding them together. That's our sum. So I'm just going to call it s. I'm going to get x squared plus, and now we know what y is. So I'm going to plug it in, and I'm going to get 2x minus 3 squared. Please make sure that you are squaring carefully. We've talked about perfect square trinomials. We talked about the patterns. So when you multiply this out, whether it's in your head or whether you do it on the side, right, with the two brackets, you end up with 4x squared minus 12x plus 9. And so my equation here would be 5x squared minus 12x plus 9. Now, if you notice for the homework questions so far, I'm just going to scoot back, they've all been parabolas. This guy was a parabola that points downwards. This guy was a parabola that points downwards, right? So your vertex is at a maximum point. This guy is a parabola that points downwards. It's harder to see because the numbers, but you have a negative r squared here and negative r squared here. That's kind of a harder one to see. This guy is a parabola that points upwards. This guy is a parabola that points upwards. And recognizing these parabola type shapes is going to be, again, really important for the work that we do this week. Okay, so now I'm going to go away a little bit from the parabola ones and just get you guys to be able to straight up translate. A manufacturer wants to design a box with a square base. So right away, I'm going to start drawing it. So anything that I can sort of visualize, I'm going to do that. A square base means that this length and this length are the same. And an open top means that there's nothing on the top. The surface area of the box is 108. Okay, so that's the given information. It's the number that we have in here. So I need to put some let statements on here. I'm going to call this x. That means that this is also x, but I don't know the height because it's not a cube. And let's find the surface area. Surface area is the surface of all these sort of pieces that put together the box. So this one is x times h, that one is x times h, the one around the back is x times h, the one around the other side here is x times h. So the surface area is going to be 4xh's, and then the bottom of the box has to be closed to actually hold something, so then I'm going to put x squared. There's no top to the box, so I'm not going to put another x squared there. And we know that this is 108, and that's my given information sitting in here. Find an equation that could be used to find the volume of the box. Okay, so the volume of the box, remember, is length times width times height. So that means that the volume of the box is x squared times height. So if this is the equation that you're trying to work with, you have to get rid of either the x squared or the h. And again, I think it's probably easier for me to get rid of the h because I don't want to square anything. So I have to solve for h in this equation right here. I get 4xh is equal to 108 minus x squared. I'm going to divide by 4x, divide by 4x, divide by 4x. Everything gets divided by 4x so that I get the h by itself. 108 divided by 4, you can start using your calculators now. So that's going to be a 36 on the top and an x on the bottom. And here, if I've got an x squared on the top and an x on the bottom, I'm left with an x on the top and I'm left with a 4 on the bottom. Be really careful about those fractions. Let's put this back into our equation. My volume is going to be x squared times whatever I found here for h. So it's going to be 36 over x minus x over 4. And we are going to, of course, distribute this out to see what we get. So my volume is going to be, do a little work on the side if you need to. You're going to get 36 times x squared divided by x. So one of the x is going to cancel. And you're going to end up with 36 times x. Remember that this is x over 1. And then when I distribute over here, I'm going to get x squared over 1 times x over 4 negative. So I'm going to get x cubed over 4, or 1/4 x cubed. And that's going to be what your equation would look like for that one. All right, how many more do we have? Oh, a couple more. All right, A manufacturer wants to design a box with a square base and a lid, so we just did that. The volume of the box must be 100. So this is a little bit different. So let's talk about the volume of the box. That's the given information, and it has a lid. Okay, so square base, we've got x, and we've got x, and we've got h. The volume is going to be x times h, and that is given to be 100. So now that's my given information right there. The base costs $1 per square centimeter to build. The lid costs $2 per square centimeter to build. And the sides of the box cost $1.50 per square centimeter to build. So let's talk about that. That's called a rate or a unit cost. So if something costs $10 per, let's do meters squared so that you don't get confused. In order to find its actual cost, how much it's going to actually cost you, like out of your pocket kind of thing, you have to multiply by something that's in terms of meters squared, because these things have to cancel off. And when you talk about multiplying by something meters squared, you're actually multiplying by the area. So that's meters squared. So let's say that's you're buying plywood or something like that. It'll cost $10 per square meter or something. Then you need to know the area of the plywood that you're going to buy, so then you could actually figure out how much that would cost you. So let's think about what this means. Okay, so what this means is that the base area in meters squared costs $1 per meter squared to build. So its cost is going to be $1 times base area. Well, let's take a look at the base area. The base area is the area of the base, which is x squared. So this is going to cost 1x squared. Then it says the lid of the box costs $2 per square centimeter. So $2 per, oh, sorry, these are centimeters. Centimeters squared times lid area in centimeters squared is going to be $2 times lid area, which is 2x squared, because the lid is x squared as well, because it's at the top of this thing here. The sides of the box, so all the sides are the same, they're all xh, cost $1.50 per square centimeter to build. So centimeters squared times sides area, centimeters squared, is going to be 150 times all the sides. Well, that's going to be 150 times 4xh, right? We've got 4xh's sitting in here, and that gives me 6xh. Okay, that's it. So what we now have is we have to find an equation for the total cost. So the total cost is going to be this guy, so 1x squared, plus this guy, which is 2x squared, plus this guy, which is 6xh. And I have to get rid of one of my variables. So I've got the 3x squared thing in here. It again looks to me to be easiest to get rid of the h. Remember that you always get rid of the thing by my given information. So I'm going to solve for h by dividing both sides by x squared. And I'm going to get 100 over x squared. And I'm going to get 3x squared plus 6x times 100 over x squared. To find my cost equation, which is going to be 3x squared, and this is over 1. So I'm going to get 600 on the top. This x and one of those x's is going to cancel over x. This one right here is not a parabola equation. Neither was the last one. So you can do these types of translation type things without things that are parabolas. We won't be working with many of them because they're not parabolas until maybe later on in the course. Okay. All right, last two. A rectangular page is to contain 24 square inches of print. So here's your poster paper or whatever, and in the middle of this you've got printed area. So this is where the printed area is going to be. So the area of that inside is going to be 24. So let's just put some variables to it. We know that x and we know that y. We know that x times y is going to equal 24. That's given information. The margins at the top and the bottom of the page are 1.5 inches. So that's 1.5 inches. This is also 1.5 inches. And it says the margins that are at each side are 1 inch and 1 inch. So let's just think for a second what our new measurements are going to be, okay? Yeah, let's do rainbow. This length along here is going to be the length of x. Actually, let's do it in blue. The length of x plus the one on the side and the other one on the side. So this is going to be x plus 2. And this length along here is going to be the length of y plus the 1.5 at the top and the 1.5 at the bottom. So this will be y plus 3. Now it says, find an equation that you could use to find the size of the paper that is used in terms of one variable only. The size of the paper is a little bit vague, so let's just do it with area, okay? That way we can, area includes length and width, so we can definitely do area. The area of this thing is going to be x plus 2 and y plus 3. So when I expand this thing out, I find it easier to expand out first. So I'm going to get xy plus 3x plus 2y plus 6. And now I have to get it in terms of one variable. So remember, we're given this thing right here. X plus x times y is 24. So right away, right here where I see x times y, I can replace that with 24. So now I've got area is equal to 24 plus 3x plus 2y plus 6. And now I just have to get rid of either x or y. So I'm going to take this first equation and I'm going to divide both sides by x, and I'm going to get 24 over x. And so now my area looks like this. I'm going to collect my like terms. 24 plus 6 is going to be 30, and then 3x, and then 2 times y. So 2 times 24 over x is going to be 48 over x. And you've got yourself an equation for the area of the printed page. Again, not a parabola, so we're not going to be doing completing the square and stuff like that with that one, but it could very well come in handy a little bit later on. All right, last one. Okay, let's see what this diagram looks like. A person in a rowboat 2 miles from the nearest point, okay, so this part right here is 2 miles, on a straight shoreline wishes to reach a house. There's the house right here, very fancy. 6 miles further down the shore. A person can row at a rate of 3 miles per hour, and they can walk at a rate of 6 miles per hour. Find an equation that you could use to find the time required to reach the house from the rowboat's crew. Okay, I can read this. So, all right, that got cut off. So let's do question number 8 from homework on day 5, unit 4. The first thing is that this little length right here is 2, and this length right here is x. And so I could find using Pythagoras what this length is. So 2 squared plus x squared is equal to, let's call it d squared. 4 plus x squared is equal to d squared. To find my d, I'm going to square root both sides. Remember that you can't square root one thing at a time. And so what you get is that this distance is the square root of x squared plus 4. Okay. We also know that this whole distance right here is 6 to the house. We know that this piece right here is x, so that means that this piece right here has to be that total distance of 6 minus x. And what happens is that the boat goes across the water. I'm going to make this. The boat goes across the water and then walks along here. Okay? So one of the things we should see is that this is also a rate question, that if you can walk 3 miles per hour, you would have to know the number of hours to actually figure out how far you're going to travel. So what we need to be able to do is we need to be able to figure out each of these things. So let's talk about by boat. By boat, they can row at a rate of 3 miles per hour. So they're going to go 3 miles per hour times the time on the boat. And what that will give you is that will give you, and this will be in hours, that will give you the square root of x squared plus 4, because that's how far they went. So the hours are canceling. And we'll call the time on boat, let's call it TB, maybe not a great thing. Now we're going to do the walking. They can walk at a rate of 6 miles per hour times time walking in hours. and that gives me 6 minus x. So the hours cancel off. We're going to call this 6 miles. Okay, and the time walking, let's call it TW. So here's my two equations. I've got 3 times the time boating is equal to the square root of x squared plus 4, and 6 times the time walking is equal to 6 minus x. That means that the time boating would be the square root of x squared plus 4 all divided by 3, and the time walking would be 6 minus x all divided by 6. The question says, find the time required to reach the house. So the total time that we're dealing with is going to be the time boating plus the time walking, which will be the square root of x squared plus 4 over 3, and then 6 minus x over 6. This question is considered to be sort of, well, not really sort of, this question is considered to be our super deluxe question. So I hope some of it sort of makes sense about the rate and how we actually found this. And again, the better you are at sort of reading these questions and translating, the easier the rest of it all will be. Alrighty, off I go.